Okay, moving along. Let me bring MATLAB up to here again. Okay, so um, what's next? Um, I want to do statistics a little bit first. If you go to this thing, I suppose there are various ways of doing simple statistics, mean, sum, minimum, maximum, variance, standard deviation, correlation coefficients, and things like that. Just like in MATLAB, although the syntax is a bit different. So if you have some function p, if you go mean of p, in MATLAB, it actually gives you column-wise mean. So 2.5 is the mean of 3 and 2, 3.5 is the mean of 4 and 3. And if you want to do row-wise means, you have to go, you have to do something like this. That's column-wise means, I guess. If you want to take the means along the rows, you have to do this, which gives you the mean of 3 and 4 is 3.5, and the mean of 2 and 3 is 2.5, and that's what you get here. In any case, we can do something similar in Python. Let's try that. So this is mean along each dimension. This is mean along rows, so that it gives you two columns, and then this is mean along columns, so it gives you two rows. In any case, we can do print. Let's go back to our favorite variable b. We have two rows and three columns, and let's do np dot mean of b. Let's try that, and let's do a print of that. Gives you a single number, which I think is the mean of all the numbers in that matrix. And if you just want like the mean along the rows or columns, you can go p comma 0. It gives you 2.5 and 52. Why is that? Oh, sorry, that's p, not b. Let me do b. Okay, so this now does along the rows, because 0 corresponds to the rows. So along the rows, so because there are two rows and three columns, it gives you the average of 3 and 2, which is 2.5, the average of 1 and 1, which is 1, the average of 4 and 1, which is 2.5, and that's what you get. And then if you do print np.mean of b comma 1, it gives you the mean of these three things and the mean of these three things, which are 2.66666 and 1.333. Okay, and you can replace it with variance. You can replace with sum, minimum, etc. Standard deviation. Okay, so I'll not repeat those things here. Those should work roughly the same. Okay, so that's about statistics for now. Very basic statistics. Let's do Boolean. So what does Boolean mean? It means like basically logical operations. So if you have b, and then if you go b of b greater than 1.5, and then it'll give you a logical array where 1 means true, 0 means false in MATLAB, and when 3 is greater than 1.5, of course, it gives you a 1. 1 is not greater than 1.5, it gives you a 0, that's false. We can do the same thing. So let me add a code block here. So let's try b greater than, let's say print be greater than 1.5. Let's try that. Exactly the same thing as MATLAB. True, false, true, true, false, false, true, false, true, true, false, false. Okay. In MATLAB, we can do b of b greater than 1.5, in which case it will just give you those values of b that are greater than 1.5. So 3, 2, and 4, going column by column, 3 to 4. And we can do the same thing in Python as well. B of b greater than 1.5. Let's see if that works. Okay, so that seems to have worked well. Pretty much identical to how it works in MATLAB. Okay, 3, 4, 2, 3, 4, 2. I guess in this case, the ordering is different. It gave us row-wise instead of column-wise, but basically the same set of numbers. So it gave us 3, 4, and 2, true, true, and true, rather than this, this, and this in MATLAB. So there are small differences here. What else can we do? By the way, we can, just like in MATLAB, when we have a logical array like this, we can go all, which means, well, in this case, it does, are all this column true, or all this columns true, or all this columns true, and gives you true if all of them are true, all of them are true. In this case, because only one of them is true, it gives you a false here. You can do the same thing in Python, although I think it does np.all. You can go b greater than 1.5. Let's see what that gives us. It gives you a single answer. It basically does all on the whole matrix here and gives you true only if everything is true. And then if you want np.any, and gives you true if any one of them is true. And because some of them are true, it gives you true. And to simulate that in MATLAB, you have to go all of all, because MATLAB by default does this dimension-wise thing. So any in Python is any of any, how many ever dimensions there are for the matrix. Okay. So that's for logical operations there, and indexing using what are called Boolean variables. These are called Boolean variables or logical variables, basically true or falses. Okay, what's next? We can try and. Let's try how to do and in so let's try b greater than 1.5 equals c, and let's say d is b greater than 2.5, and then print c, print g. So slightly different matrices, C and D. And then see if we can do C and D. Let's see if that works. Okay. That doesn't work. So if it doesn't work, let's just go and in Python or Numpy. And basically it does numpy.logical underscore and. Okay, so that's how you do it. Let's try that. So you can try to guess things, or you can go do Google searches, logical and, okay. And then we go C, comma, D, print, and if it's true, if both of them agree, it's a true, and then, but if only one of them is true, it will be a false, okay? So this is true and this is false, so you get a false, and so on. You can look for logical or, etc. In MATLAB, of course, we just go something like this. So that's how you do b greater than thing, and so if both of those things are true, you get a true, okay? So it's good to, if you're familiar with one language, it's good to see how the constructs differ in a different language or a different library. Okay, so the next thing I want to do briefly is loading from files in Colab, and maybe I can do that in the next video. Okay, maybe I'll just spend another couple of minutes in this video and complete that. So in Colab, if you go to these tabs, if you click on this, this is kind of a file folder directory thing. So this is an image, which it's actually an image that I used to respond to one of your questions. It's a screenshot of my previous Colab notebook from yesterday. And then I also have another file here, which is just a file with 3 rows and 4 numbers in each rows. Okay, so a very simple text file. Okay, I'm going to essentially drag and drop these things into this folder. So I've just dragged and dropped these things into this folder, and let's see if we can actually load these things into Python. How do we do that? Let me go back to my Numpy notes here. Close. Okay, so if I wanted to import this image, so it's not quite a matrix, it's an image. So to do that, we need this library called there's a package called skimage, and from that package we are importing. So you can import the whole package, everything in that package, or you can import just specific modules inside that package. So there is an image processing sort of package called skimage in Python, and I'm importing just a particular module in the package called IO. Let me just run that. And then once you've done that, you can do something like this, some qr, some variable called r, io.imRead. So the imRead is just like in MATLAB, except there is io.imRead, and then it goes screenshot that, I think it's a PNG file. You can just run that. So, so what is R? We can say R dot size or shape, print R dot shape. So it's a 1152, 668, 4 matrix. So that's interesting. What's this for? I'll let you think about it, examine it. So it's a matrix in any case. It's a 3-dimensional matrix. And then if I wanted to import So because the matrix, we can go, I don't know, 3 comma 4 comma 5 like that, and oops, ah, I did 5 there, even though there's just 4 slices there. So let's do 2. Anyway, so apparently that's a white pixel, or it's maxed out. Um, okay, so let's see. Um, let me import, well, let's, given that we've imported this image, let me just plot that image. And to actually show the image, we use matplotlib.plt, and then you go plt.im show of r. Let's see what that looks like. Okay, so this is actually the image that I just showed. Guess the same image there, like so. So Python knows how to interpret that matrix. Let me quickly try to import this data file, which is just a very simple, basically this data file, 3 rows, 4 columns. It's what's called a comma separated value file. I've named it as txt, but you could name it as CSV, which stands for comma separated value file. In any case, if you want to call that or import from that data file, we can import it like this. I think where I'm calling it data in file dot txt. And then because it's a comma separated file, we say the delimiter, like the one that is separating the different values, is a comma. And then we can just go that. Now, if I say print s, and you will notice that it's the exact same set of values: 3, 44, 5, 6, 3, 44, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 7, 8, 902. Okay, so that's how you get data into Python, or at least one way of getting data into Python or Numpy. You can check what kind of data type it is. It's a NumPy n-dimensional array, which is what we've been using so far. Because it's a NumPy array because we used NumPy to import this data file. We can also save to data files. So save text is the command for that, apparently. So let's just define pqrst equals, let's say, 2 times s, run that, and then we can go np.save text. We have a file name, file containing t or something, I don't know, .csv, and then we can say delimiter equals comma, and then run this thing. Doesn't work. Let's see why it doesn't work. It says it requires something else. Okay, so what like we haven't told it, for instance, what variable we are supposed to store. So we have to do that first. Okay, so if you go save text, it's file name, the variable, and then the format. Okay. Okay, now it's happy. Now we have a new file called CSV, file name containing CSV. You can say download, allow. Okay, we've downloaded it. You can take a look at it. It'll be fine. Okay. It just went into my download folder. Okay, so that's all for like importing and exporting to files, at least as text files. Okay, um, so let me stop that video there, and then I'll let you guys puzzle out why this said. So this is the number of rows, I guess. This is the number of columns, and then this is slices. So why is it 4? I'll let you think about it and explore that.